You ever stop and think about the one piece of technology that's just everywhere? I mean, it's as essential to your life as the air you breathe, but you probably never, ever think about it? Well, today, we're pulling back the curtain on the invisible engine that powers, well, everything.
You know, more than 100 years ago, Nikola Tesla had this massive vision. He knew that really mastering electricity wasn't just about, turning on a light. It was about completely transforming the entire planet. And the wild thing is, he was so right.
And that transformation he was dreaming about? It's not some far-off sci-fi future. It's happening right now. It's in the phone in your pocket, the car you drive, and in the giant data centers that run our whole digital world. And it all comes down to one incredibly powerful, but totally hidden, technology.
So what is this secret engine? It's all part of this quiet revolution in how we manage energy, a field that goes by the name of power electronics.
Okay, so that's the official textbook definition. And yeah, it sounds a little dry, I'll give you that. But what it really means is that power electronics are basically the brains that tell electricity exactly what to do. They grab power from a source, like a battery or the outlet in your wall, and they shape it, they condition it into the perfect form a device needs to work. So just how important is this stuff? Well, take your smartphone. You see the screen, you see the cameras, but deep inside, something like 40% of the main circuit board is dedicated to just one thing: power electronics. 40%! All that real estate is just for managing the flow of electricity. It's incredible.
And it's not just phones, not by a long shot. This technology is absolutely everywhere, hiding in plain sight. It's the beating heart of those massive data centers that power the internet. It's what makes electric vehicles even possible. It's managing our renewable energy grids, running life-saving medical gear, and yeah, it's even making your dishwasher run more efficiently. Oh, and that little brick that charges your laptop? Yep, that's all power electronics.
But to really get why this is so revolutionary, you have to understand the huge problem it solves. We're talking about a problem of incredible, staggering waste, a massive billion-dollar heat problem.
All right, let's just imagine a simple, everyday thing. You're in your car, right? The car's system runs on 12 volts. But your phone, it needs a nice, stable 5 volts to charge. So how do you do that? How do you get from 12 volts down to 5?
Well, the most obvious way, the sort of brute force approach, is to just resist the flow of electricity. You could use a component, like a transistor, to basically act like a dam, fighting against the current to push that voltage down from 12 to 5. But there's a huge catch. All that energy you're blocking, it has to go somewhere, and where it goes is into wasted heat.
And if you look at this chart, you see just how bad this method is. I mean, the math is just brutal. For every bit of power you're pulling from your car's battery, only about 42% of it actually gets to your phone to charge it. The rest of it, that huge 58% bar, is just gone, poof, turned into pure useless heat.
So what you've built isn't really a phone charger. It's a tiny, very expensive, and very inefficient space heater. Now just try to imagine that level of waste on the scale of a giant data center or an entire electric car. It wouldn't just be a problem, it would be impossible. You'd literally melt your devices from the inside.
So this is where the absolute genius of modern power electronics comes into play. Instead of fighting the electricity with brute force, it outsmarts it. It uses an incredibly elegant solution that we can call the magic of the switch.
And this right here, this is the core difference. The old, dumb way resists energy, and that makes heat. But the new way, what's called a switched mode converter, it doesn't fight the energy at all. It redirects it. It cleverly stores it for a split second and then releases it in exactly the right way.
So here's how this magic trick works. First, a tiny electronic switch starts flipping on and off millions of times a second, chopping that incoming 12 volts into a stream of tiny little energy packets. Then, the energy from each of those little packets gets stored in components that act like tiny rechargeable batteries. And finally, all that stored energy is smoothed out and released as a perfect, steady 5-volt output. No fighting, no waste.
There's this fantastic quote from the MIT lecture this whole explainer is based on that just nails it perfectly. The whole magic is about using elements that are, for all practical purposes, lossless. You don't burn the energy. You just draw it in, process it, and send it out the other side. You're not destroying the extra voltage, you're just repackaging it.
And the result of this clever little repackaging job? Remember that pathetic 42% efficiency we saw before? Well, with this switching method, we can now get efficiencies of over 97%. That's right, almost no wasted energy, almost no heat. It's a complete game changer.
So why does all this matter? Why is this such a big deal? Because that incredible jump in efficiency, going from wasting over half your power to wasting almost none, is what makes our entire modern world tick.
I mean, just look at the payoff. When you stop turning energy into waste heat, devices can suddenly get way smaller and lighter. The battery on your phone can last dramatically longer. Computers can run cooler, which lets them get way more powerful. In just one redesign of the Toyota Prius, simply improving the power electronics boosted its fuel economy by 5%. This isn't just a small step. It's the key that unlocks things that were flat out impossible before.
And what's really amazing is that this one core idea, the magic of the switch, scales across absolutely everything. From the tiniest little milliwatts running a sensor to the massive gigawatts flowing through our power grids, this invisible engine is the common thread, quietly and efficiently making it all work.
You see, this is the unsung hero that made our world portable, that made our data centers possible, and that is making our renewable energy future a reality. It has changed everything in ways we just take for granted now. So the only real question is, where is this invisible engine going to take us next?